Welcome back to class. In this lecture, we learned that the number of banks within the German banking sector decreased significantly over time. Therefore, we introduced different shakeout theories, and we performed a microeconomic review in order to understand one specific shakeout theory, which will be rolled out within this part of the lecture. Let's have a look at the assumptions. We are looking at the market structure of perfect competition. There are n homogeneous companies. They use the same technology so that all the firms have the same cost structure and the same cost function, which is given there. We can simplify our analysis by focusing on one representative company because of the fact that all the companies, they are producing with the same technology and they have the same cost structure. The market supply, QS, depends on individual supply. So the quantity supplied in the market is equal to N times Q. N is the number of firms within the industry and Q is the output of the individual company. The market demand, large QD, depends on the price, and the demand relationship is given by demand is equal to 1000 minus the price. So the lower the price, the higher the demand for this good. The endogenous variables are the quantity supplied by one company, the price, the quantity supplied by the market, the quantity demanded in this market, and the number of firms within this market. How can we find these 5 different endogenous variables? In a first step, we have to find the minimum of the average cost. So we have to differentiate the average cost function with respect to the quantity, set this equation equal to 0, and we find the output, which leads to a minimum of the average cost function. When we have this information, we can derive the price. When we know the price, we know the quantity demanded in this market. When we know the quantity demanded, we also know the quantity supplied. And in a last step, it is the case that we can compute the number of firms within the market. The assignment questions are as follows. In the first step, compute the quantity Q, which leads to a minimum of the average cost function. Second step, compute the minimum of the average cost function. Third step, compute the market demand by using the long-run optimality condition, like price is equal to the minimum of the average cost. And in a fourth step, we should compute the numbers of firms operating in the market. Let's think about the optimal quantity. The cost function is given in equation 6. This was given. And when the cost function is given, it's very easy to compute the average cost function. So we have to divide the cost function by Q and get the average cost function. This is given by 4Q plus 100 plus 100 divided by Q. When we want to compute the minimum of the average cost function, we have to differentiate the average cost function with respect to Q. Let's do so. We get 4. When we differentiate 4Q with respect to Q, we get a 4 here. When we differentiate with respect to 100, this drops out. And when we differentiate with respect to this Q here, we get minus 100Q squared. This first derivative has to be set equal to 0. when we put the minus 100q squared on the other hand side of the equation, we get to this relationship here. And then when we put the cube squared on the other hand side of the equation and the 4 to the other hand side of the equation, we get q squared is equal to 25. So that the optimal output in this industry is equal to 5. This quantity of 5 implies that each company which is producing in this market will choose the optimal quantity of 5. This leads to a situation where the average cost is at a minimum. The average cost function was given by this relationship. The optimal quantity was given as Q star is equal to 5. How large are the average costs in case that the company is producing the output equal to 5? When we insert the quantity of 5 into the average cost function, then it becomes clear that the average costs are equal to 140. So it costs on average 140 euros to produce one of this unit of output. Therefore, when we know this information here, it is the case that we know that the minimum of the average cost function is at the level of 140 and that the price in equilibrium will be equal to 140 euros. This is very important information because now we know the output of each and every company. The optimal output is equal to 5. The minimum of the average cost is at the level of 140 euros and the price will be equal to 140. In the next step, we can insert the price into the demand relationship and we get the information about the quantity demanded in this industry. So this is now given that the price is equal to 140 and we can compute the quantity demanded. We have to insert the price into the demand relationship and then we know that the demand will be equal to 860 units. 860 units will be demanded, but will also be supplied by the market. It will be supplied by the market, and hence the quantity supplied will also be equal to 860. We also know that a single company will produce the quantity of 5, and therefore we are able to compute that in this industry 172 different companies will survive in the long run equilibrium. 172 companies are producing in this industry. In this first part, we characterize the situation on this market before an innovation took place. The optimal quantity for the single firm was equal to 5 units. The price was equal to 140 euros. 860 units were demanded and also supplied, and the number of firms operating in this industry was equal to 172. Now we'll assume that an innovation takes place. This innovation leads to a new technology and to a new cost structure. This new technology reduces variable cost, but it is increasing fixed cost. You can see here the old cost function. Fixed cost increase from 100 to 200, but variable cost decrease from 4q squared plus 100q to 2q squared plus 50q. The conclusion is that this innovation leads to a different cost structure there are higher fixed costs but lower variable costs. Once more, I would like to perform like all the computation necessary to characterize the market structure after this innovation has taken place. So we have to do the same computations as before. We have to follow this recipe in order to characterize the market structure after the innovation has taken place. We have to compute the quantity which leads to a minimum of the average cost function. We have to compute the minimum of the average cost function. Then we can compute the market demand and the number of companies operating. Let's do so. The new cost function is given by this relationship here. We have to compute the average cost function in the following way, that we divide the cost function by Q. We get the average cost function. Now we would like to find the minimum of the average cost function, so we have to differentiate the average cost function with respect to Q and set this relationship equal to 0. When we do that, we get this first derivative of the average cost function. We set this equal to 0. Then we can put the minus 200 q squared on the other hand side of the equation. When we put 2 on the left hand side, the q squared on the right hand side, we get the information that q squared is equal to 100. And when we take the square root of this relationship here, we get the information that now the optimal quantity is equal to 10. So due to the fact that this innovation has taken place, which led to an increase of the fixed cost, but a reduction in the variable cost, the minimum efficient square increased. It increased from Q star is equal to 5 to Q star is equal to 10. So each company has to produce a larger amount of output in order to reach the minimum of the average cost. This is mentioned on slide number 29. So the new optimal quantity is larger than the old optimal quantity. The minimum efficient scale has increased. What about the minimum of the total average cost in case that Q star is equal to 10? When we are inserting this information in the new average cost function, we get the information that now the minimum of the average cost is at 90 euros. So it follows that after the innovation has taken place, the price will decrease from the level of 140 to the level of 90. The price decreases in this market. When the price decreases, of course, it will be the case that the quantity demanded will increase. So when the price is equal to 90, the quantity demanded is equal to 910. The number of firms operating in this market is equal to the quantity supplied in the market divided by the quantity supplied by the individual firm, like the number of firms which are surviving this shakeout is equal to 910 divided by 10 is equal to 91. So the new number of the number of firms is equal to 91. So we can see here that in this industry a shakeout has taken place before the innovation took place, which had an impact on the cost structure. 172 firms were operating, and after this innovation has taken place and some companies left the market, it is the case that 91 firms still survive. Hence, we are able to explain by this theory why it might be the case that the number of firms in the German banking sector reduced over time, It might be the case that there is an innovation which influences the cost structure, which leads to higher fixed costs but lower variable costs, and then the number of firms in this market will decrease. What could that be? Of course, digitalization could be one driver. Digitalization comes along with higher fixed costs, but it lowers the variable cost of banking. So it might be the case that digitalization is one driver of this development of the German banking sector, which we are looking at in this lecture. Thank you very much for attending this lecture. Thank you. Have a nice day. Bye bye.